Afternoon.
Good afternoon.
So how's everyone feeling today?
Pretty good.
All right. Well, I guess let's start off with attendance here. Oh, brother. All right, let's see. So is everyone there at Mogyon?
No, Jordan's gone.
Jordan's gone. She actually emailed me and told me that. All right, how about Hopi?
We're just missing Alan.
Oh, that's right. And how about Alchse?
We're all here.
Okay. Okay. So today is going to be our last day of new material. So I hope you're excited about that. Can kind of see light at the end of the tunnel. We'll talk about near the end of class. We'll talk about what we're going to do Monday, and we'll kind of have a vote on that. But I just want to tell you that this last week, this is the push to really do a good job. This is not the time to say, well, I'm not going to do the extra credit, or I'm not going to study, or whatever. I just want to remind you that this is a college class, and you need to study. You need to study for the final. If you go to any college campus during exam week, students are holed up in their dorms, and they will just be studying for days to try to, pull out a good grade or whatever. So just know that when I write this final, my expectation is that you've been studying, you've been practicing. Okay, so it's not the time to, it's not the time to take it easy. This is the time to really pick it up and really work hard this last week. So I just want to share this thought with you by Dr. Strange, who says, we're in the end game now. All right. So this is the time to really step it up. Okay. And do a good job. So anyway, so we're in the end game. We're in our last week, really, of the class. So here we go. All right, so I'm going to start with finishing 11.6. Does anyone have any questions, comments, concerns before we work on 11.6?
Yeah, I have a question. Does this mean that there's like a 1 in 14 million chance that we'll all pass?
Well, let's say I would say since we're talking about probability, I would say would be the odds of you all getting 100 on the final. Okay. So I think the odds of you all passing are much higher. So anyway. And, anyway. Okay. So we're going to, let me switch cameras here. And so this is kind of where we left off last time. We were talking about the probability of a union of events. And this was where you had, in this example, is where you have two events that do have an overlap, okay? So we talked about the ones that don't overlap are called mutually exclusive. In this example, there is an overlap. So let's talk about that. So as we were talking about like girls with glasses and so on, you might remember in the last class. So here, this one says one card is selected from a standard deck of 52 playing cards. What is the probability that it is either a heart or a face card? Now, I like this example because we've got kind of a picture of what's going on. So if you draw kind of a set of all of the hearts, ace through king, so there's 13 out of 52 hearts. And then you draw a picture of all the face cards. So jack, king, and queen of each suit. So 3 times 4, so 12 face cards. So you say the probability of drawing a heart is 13 out of 52. The probability of drawing a face card is 12 out of 52. But then you have to subtract 3 out of 52. Why? Why do you have to subtract that?
Because there's those 3 that overlap and they apply to both sections.
Yes, and so if you didn't subtract, you'd be counting those 3 twice. Okay? And so you have to subtract that overlap, the jack, queen, and king of hearts. So then to do the final answer, then you have 13 plus 12, 25 minus 3, so 22 out of 52, which simplifies to 11/26. All right? So any questions on that? All right, well, let's see if you can do this practice 3C. All right, so Veronica, when you've got it.
One third.
1/3. Let's see if you're right. I'll tell you, that seems to be a little high I think, but we'll see. Because, see, one card is selected from a standard deck of 52 playing cards. So what is the probability that is either a club or an ace? So first, you figure the probability of drawing a club is 13 out of 52. There's 13 clubs out of the 52 cards. Okay, then the deck has 4 aces, 1 of each suit. So the probability of drawing an ace is 4 out of 52. But then you have to subtract 1 card, which is the ace of clubs, because otherwise it's the overlap. It would be counted twice. So your answer is going to be 13 out of 52 plus 4 out of 52 minus 1 out of 52, which is 16 out of 52. So 4/13 or 30.8%. Okay. Actually, 1/3, I mean, that's not a bad guess, but it's not the right answer. I mean, it's pretty close. All right. So any questions on that one? Okay. Okay, now, if there are no overlaps, then that's what we call mutually exclusive sets. And there you just add the probability. So like in this example, it says the personnel department of a company has compiled data on the number of employees who've been with the company for various periods of time. The results are shown in the table. All right, so here's the number of years of service, and then how many employees fit in that category. All right, so let's say they pick an employee at random. We want to know what's the probability that that employee will have been with the company for less than 10 years. Okay, well, so less than 10 years, that means either this category from 0 to 4 or from 5 to 9. So is there any way that you could be in both of those categories? Is there any overlap to those categories? Is there anyone that would fall, any of these employees that could be in both?
No.
No. No. And so what that means is you don't have to worry about subtracting any overlap. Okay? There's no one that you're going to count twice. So to calculate the probability, then you would just add up these two numbers and divide by the total amount. Okay? So you take 157 plus 89, and you'd add these two probabilities together. And so then you'd end up with 246 or 529 or 0.465, 46.5%. Okay? So you're just strictly adding them up if there's no overlap. Okay? Any questions? All right, so I'd like you to try this one. All right, so Hannah Z, when you've got it.
$47%.
47%. Because, see, here we want to know the probability that a person selected is from one of these two age groups. And you can't be there, you can't be in both. There's no overlap here. So it's just strictly adding 27% and 20%, and you get 47%. All right? Good job. Okay. Now, next we want to talk about independent events, where one thing doesn't affect the other. So let's say you're flipping a coin and rolling the dice. Those are independent events. So it says if A and B are independent events, then the probability that both A and B will occur, the probability of A and B, is the probability of A times the probability of B. That is, to find the probability that both independent events occur, you find the probability of each and multiply. So let's say you flip a coin and roll a dice at the same time. You want to know what's the probability that you'll get a heads and a 3 on the dice. Well, then you say, okay, the probability of getting a heads is 1/2. The probability of getting a 3 is 1/6. So then you multiply those together. Okay? All right, any questions? Okay, is there a question in Mogyan? Do you guys have a question? No? Okay. All right, well let's so you just multiply. All right, so let's just have you try this one. All right, so Rhett, when you've got it.
.134.
Okay. There you go, 0.134. So, because you want to know the probability that each one is less than 12 when you randomly select a number from 1 through 30. Well, there's 11 numbers, 1 through 11, that are less than 12. So the probability of the first one being less than 12 is 11 out of 30. And that doesn't affect the choice of the next random number. So it's also 11 out of 30, and so you just multiply those together, 121 over 900, or as a decimal, 0.134. Okay. All right, good job, Rhett. Any other questions on that one? Okay. All right, so when solving problems involving multiple events, the first question you should ask is, are they independent events? Or are they mutually exclusive? Because, see, if they're independent, then you're going to multiply. If they're mutually exclusive, you're going to add. And so you kind of have to know what's going on. And so learning how to recognize when it's mutually exclusive, a couple of things I would recommend to you. First of all, I would say have this paper in front of you when you're trying problems, because you'll say, oh, that's kind of like this one. And then I would recommend you doing some practice problems just to set up to make sure that you can recognize. It's just like before when we're talking about recognizing whether it's a permutation or a combination. These problems, their math isn't difficult, but you have to recognize the situation. And that comes with practice. Okay, so it says in 2000, approximately 65% of the population of the U.S. was 25 years old or older. 10 people were chosen at random from the population. What is the probability that all 10 were 25 years old or older? Okay, so let's kind of think about this. If you're the first person that's chosen, okay, what's the probability that you are 25, well, not you exactly, but the first person chosen, what's the probability that they are 25 years old or older?
65%.
65%. Now, does their answer affect the next person's probability? If you're the second person that's being asked, What's your probability of being 25 years or older? Still 65%. See, because if they ask somebody else, that doesn't affect your answer. Okay? So this is an independent event. Asking all these people to survey, these are independent questions. Each person's answer is independent of the last one. So that means we're just going to multiply these. Multiply all 10 of them? Yes. So each answer, the odds are the probability is 65%. So to get all 10 of them to be 25 years or older, the probability is going to be 0.65 to the 10th power. Because it's 0.65 times 0.65 times 0.65 for all 10 people. And so then you put that in your calculator and you get 0.0135 or 1.35%. Okay? Now, I forgot to play wits and wagers here. I was going to have you guys guess what you thought. And it's really interesting because most people, when they guess something like this and they're not calculating it, most people are horrible guessers. Okay? And I tell you that because when you're taking a quiz or the test on this, usually your gut feeling is going to be wrong on these problems. Okay? Most people will say, oh, probably, I think the last class, the most common guess was right around 30%. Okay? And it ends up being 1%, a little over 1% is the probability that it would happen. Okay? So you really do need to calculate it and figure it out. Just looking and guessing is probably not going to get you the right answer on these. Okay? All right, any other questions on this one? All right, so let's try this one. Okay, actually, before we do too much more calculation, let's go ahead. I'll teach you how to play Wits and Wagers. It's actually a board game. Have any of you played it? Any of you played? Yeah, okay. All right. So, Rhett, since you've played it, I'll let you kind of be our guesser here. Okay? So, between 0% and 100%, what do you think the answer is? We're not, without calculating it here. What's the probability that a sale will be made with each of the 5 contacts? So between 0 and 100, just give me an answer without using a calculator or anything. No, don't be telling him the answer.
Like,
What do you think? What?
like,
So just give me a number between 0 and 100.
oh wait, 30%.
30%. Okay, so now let's vote if you think the true answer is higher than 30% or lower than 30%. All right, so how many of you think the true answer to the probability that a sale will be made with each of the 5 contacts is higher than 30%? Raise your hand. All right, so how many of you think it will be lower? Okay, so that's kind of how you'll get points, is if you guess that right. Okay, so let's actually work it out now, if you haven't. All right, so Lainey, how would you calculate the actual probability here?
Would you put 1/3 to the power of 5?
Yes, that's it. That's exactly it. So 1/3 to the power of 5. Okay. Which, so 1 to the 5th is 1. 3 to the 5th is 243. So you can leave it as a fraction, but if we convert it to a percentage, it's less than 1%. Less than 1% is his probability of making a sale on all 5 contacts. Okay. So anyway, so the way the game works is that if they actually ask you if you think it's lower or then way lower or whatever. And so there's ways to get points that way. So anyway, and then if your guess is within, it's pretty close, then you get even more points. Now, I actually played this game, and there are some problems that are like this, where it's kind of a probability thing. And so I would calculate it, and I would get like the exact answer. And everybody's like thinking I'm some kind of a magical genius or something, and it's just doing probabilities. Okay. So anyway, some of them you have to know stuff or whatever. But. Okay. So now this is kind of the last big idea here in the section and in the chapter is what's called the complement of an event. So here in this connotation, complement, it's not like, you guys are great students, okay? Not that kind of a compliment. The complement is if something goes the opposite of what you think it should be, or that the probability that it doesn't happen. So here it says if A, well, first of all, the notation, the complement of event A is denoted by A and then this little slashy thing. I just read it as A prime. Okay? Because the probability of A or A prime is 1, so either it happens or it doesn't happen, then, and these are mutually exclusive, then it follows that the sum of their probabilities is 1, and then this is the big idea, this last statement here, is the probability of a complement is 1 minus the probability of A. So if I said, okay, if I roll the dice, what's the probability that it doesn't come up as a 3? Well, you could say, well, that's the probability of 1 plus the probability of 2 plus the probability of 4, 5, and 6. Now, the easiest way to do that is to say the probability that comes up at 3 is 1/6. So the probability that it doesn't come up 3 would be 5/6. Okay, just subtract it from 1. Now, so that actually relates to this problem here. Okay, it says the sales rep. So we're back to the same salesman. Sales representative makes a sale at approximately 1/3 of all calls. If on a given day the representative contacts 5 potential clients, what is the probability that a sale will be made with at least one client, one contact? The problem here is the word at least. Because if you try to just do this as a straight up probability problem, what you would have to do is calculate the probability that he makes one sale plus the probability that he makes 2 sales plus the probability he makes 3 sales and 4 sales and 5 sales, and then add all those up. Okay? That's a pain. The easier way to do this would be to think, okay, if the probability that he will that a sale will be made with at least one contact. So 1, 2, 3, 4, 5 just means that it's not what? That he doesn't make how many sales?
0.
0. So then what we could do here is calculate the probability that he makes 0 sales and then subtract that from 1. And then that would give us the probability of 1 plus 2 plus 3 plus 4 plus 5. And so that's way easier. So see if you can do that. So first, calculate the probability that he makes no sales and then subtract that from 1. So see if you can do that. All right, so Rachel, when you've calculated the probability of 0 sales, let us know.
I got 0.13.
0.13? Okay. So, all right, so the probability that he doesn't make a sale on one call is 2/3. Because the probability that he makes a sale is 1/3, the probability he doesn't make a sale is 2/3. And so to do it for all 5 calls, it's going to be 2/3 to the 5th power, which would be what? 32 over, let's see, I think we got that worked out. Over 243. Okay. All right. So then that is the probability that he makes no sales. All right. So now what's the complement of that? All right, so Shalisha, this is the last question of the year coming to you from this. So if you miss this, then I'll spend all summer long thinking I'm a failure. So no pressure. Just kidding, kind of. All right, so what's the complement of this?
Do I minus that from 1?
Yes.
So would it be 0.86?
Yes. So 0.86, so 0.868 or 86.8%. Or you can leave it as a fraction. Okay. All right, so I don't have to cry myself to sleep tonight. Thank you, Shalisha, for coming through there at the end. Okay. And that's it. That's it for 11.6. Any questions? All right, yeah, thank you. Guys, you guys are great. And I really have loved this class. You guys have been a super class to teach, and I've enjoyed it. So we just finished 11.6. We just finished chapter 11. Okay. So the next thing we need to talk about is what we're going to do Monday. Okay. Now, traditionally, kind of what I've always done, if we had an extra day like we do, and I try to build that in. And normally what I've done is had like a review day where you come and ask me questions from the practice test and so on. But I had one of my students in another class come up to me and they said, well, Mr. Strong, being as that we just finished a chapter and we got these quizzes, it might be very beneficial to us to have a Moodle day, the last day. So we could just use that time to get all the quizzes and tests done before the final. And I'm thinking, I like both of those plans. Okay, so I'm going to just put it up for a vote. If you want Monday to be a Moodle day and we don't have class, or if we have it as a review day where you come and pepper me with questions. So does anyone have any comments, that we're going to put up for a vote? So if you want to sway your classmates or anything with your opinion. Anybody want to say anything before the vote? Okay. All right. Well, then let's just put it up for a vote. So all in favor of having a Moodle day on Monday, raise your hand. All right. So we've got 1, 2, 3, 4. Okay. So then review day, just make sure I got my numbers right. Okay. All right. So we will plan on doing a review day on Monday. Okay. So let me explain to you what I think would be a good thing for us to do is if you go to, okay, so first of all, you do want to make sure that you spend some time in the Moodle getting caught up on quizzes, tests, whatever. You want to have like that chapter 11 test done before the final. Okay, I would highly recommend that. Okay. Then when you come to class on Monday, what I would recommend you do is look at the practice test. Now you can ask me questions from anywhere, anything, but if you look at the last section under the final, so I have a practice final exam, and so here if you click on that. Then you'll see this was actually a final exam that I gave years ago. And so there's a lot more questions on this, though, than you have on yours. Okay? I think there's over 100 questions or so. But so go through that and it would be a good review. Also, the practice problems in the book, the practice tests in the book, all of those would be good to go through. Then on where it says practice final, see what I've got is when students have asked me questions on certain ones, then I post it. I don't really have a key to the whole practice final, but if there's any problem that, maybe you compare with a friend and you got different answers or you have a question, then what I'm hoping is that you'll ask me those problems. Now you can see if some of them are already worked out, maybe you don't need to ask me about number 8, but, or number 14 or something, but in between there, you might ask me any of those. And of course, maybe you want me to explain some of these. And that's okay too. And so really, if everyone will come with just one question, we'll have plenty to do on Monday. And so you can just pepper me with questions. And then what I'll do is after class, then, we'll probably have more slides to this notebook file. And so then what I'll do is I'll save it with the additional questions that you've asked, and then I'll post it back on the Moodle. So anyway, so we'll do it that way. All right, now, and then don't forget the extra credit. Okay, the 4 sources of extra credit, including the essay. Everything is due Thursday midnight. But please don't wait till Thursday midnight. Because if you say, I really the internet went out. I decided to take the last chapter test Thursday at 11:30 p.m. and the internet went out. I'm gonna say sorry, but the course closed at midnight on Thursday. So if you have internet problems where you live, you need to take it earlier. Okay, don't put it off. Okay, or if you the next week after that, if you say, "Oh, my grade is a C plus, I really needed a B for a scholarship. Can you let me take a test?" No, because the thing's closed. Okay, so a week from today at midnight is when everything's done. But like, let's say chapter 10 test, you only took it once. You want to take it again, then you can just email me and I'll open it up. Okay? And you can take it your second time. All right? Okay, so any questions, comments, concerns? All right, well, we're going to call it early today. So come with a question on Monday and have a great weekend. And remember, we're in the end game. So have a good one.
That's
So
why
we're just talking about that.
Say Monday.
See you Monday.